Welcome back to an unplanned episode of Alpha Found. Several times in video 24, I use the words with algebra or with simple algebra without showing steps. Since many of the steps are not obvious, I thought it would be best to fill in the details. Also, there are two additional identities, one of which was left out of video 24 because I felt it was time-consuming and irrelevant. Now I think it's a mistake to leave it out. It's not irrelevant. We'll begin with some simple algebra to solve for correlation. Recall identity 24.3. By moving some terms from the right-hand side to the left-hand side, we get, if we divide both sides by everything remaining on the right-hand side except for correlation, this was an intermediate step in video 24. Then I skipped to the conclusion. Let's pause for a moment and go back to identity 24.3. Since the sum of the low and high ideal betas equals 2, then the sum of the ideal betas squared equals 4. Recall that the sum of the expected h's is 0. Then we can add 0 to the above equation in the form of expected low h plus expected high h. Expanding the terms in the square gives, substituting 29.1 into the formula for correlation gives us the parts in red cancel, and then canceling the 2's from the numerator and the denominator leaves us with 24.4. If we go back to 29.1 and substitute it into 24.3, then we get another large mess. We can subtract the parts in red from both sides and get, then divide both sides by 2. 29.2 is an identity that holds regardless of which scenario or condition we are in. To find out what it means, we'll require some algebra and an example. First, the algebra. Recall that by definition, if correlation between perturbations equals 1, then the variance of the h equals 0. Plugging these values into 29.2 gives us the algebra works out when correlation equals 1. Now for an involved example. First, we need more algebra and then a prediction. Recall that in example 13.1, correlation between perturbations was set to 0, which means, from 29.2, the prediction is that once we derive the expected high h, we will know the variance of h. It will take some work to get there. From example 13.1, we have the following parameters. And as a needed reference, here is 23.2a and 23.2b. These equations will be solved simultaneously to give us expected high h and the variance of high h. First, we plug in all known parameter values. Divide both sides of both equations by 0.00722222 and multiply the terms within the parentheses. Move all the constant terms to the left-hand side. Since the expected low h equals minus the expected high h, then by subtracting the first equation from the second, we can solve for the variance of h by plugging the expected low h into equation 23.2a. Now we need to test this result by plugging the expected low h into 29.2. Identity 29.2 checks algebraically and numerically. The same technique will work for the backward model as well. Using the estimates for the low and high ideal betas used in the construction of Table 21.2, the estimated forms of equations 23.2a and 23.2b are below as equations 29.3a and 29.3b, and can be solved simultaneously to give us Table 29.1, which is an extension of Table 21.2. Table 29.1, Estimated H and Variance of H for Realized Market Data, January 2015 through December 2019. In video 24, it was claimed that inequality 23.8 was algebraically equivalent to inequality 24.5. This is not obvious. The first step is to substitute correlation from 24.4 into 23.8. That is, this into this, which leads to the parts in red cancel and the parts in blue multiply to remove the square root. The denominator of both terms on the left-hand side is the same, and so the numerators can be combined. Also, on the right-hand side, the numerators can be combined over a new common denominator. Next, the variance of the h terms are combined on the left, and the ideal high beta is factored out on the right. The left-hand side gets factored, and the right-hand side gets rearranged. Since the expected low h equals minus the expected high h, the left-hand side can be combined and rearranged, and the right-hand side gets rearranged as well. Again, since the expected low h equals minus the expected high h, the left-hand side can be rearranged, and the right-hand side becomes the difference of two squares. Multiplying out the numerator of the left-hand side gives us the difference of two squares plus an extra term. If we multiply through by the denominator of both sides, we get the parts in red can be subtracted from both sides, then we divide through by 4, which gives us 24.5. It has now been shown that 23.8 is equivalent to 24.5. This concludes this video.